relationships. So we have completed the first three lectures: introduction, historical perspectives of the database, and the conceptual database design. Today we have to discuss the relationships. So under this lesson, you have to identify the relationships. What are the degree of the relationships, the degree of the and also the cardinality ratio and descriptive relationships and the weak entities. These things you will have to identify during this lecture, and also we will try to do this lecture also as an interactive session. That means you will have to answer the questions, and I also will give you the time to do some exercises. Okay, here we have done this exercise last week. So here I think you could remember this one. So previously also here the student number, student name, student major, date of birth, student hours, student year, GPA, and average, student age. So you know that what are the simple attributes, multi-valued attributes, derived attributes. So we did this one in the previous lecture. So these are the data for that table. Likewise, you can write the data. When you see this one, you can see the major has written as IT Fine Arts. Student date of birth also 14th February 1990. There are some name also, Annette Annie. Likewise, you can find. So keep it in your mind. Then how to then you can understand what are the composite attributes, what are the multi-valued attributes. By seeing this data set, you can easily identify those things. So let's see single value attributes and the simple attributes. So you have to understand the difference of these single value attributes and the simple attributes, which we have had to fill in the last lesson. Single value attribute is one that can have only one value. Single value attribute is one that have only one value. That only one value. This is very, very important. One value. For example, person has only the first name and only the social security number. For an example, identity card number. Can a person have 2 or 3 NIC numbers? No, it cannot be. And also the employee number. Can he have more than one employee number? No, that also cannot be. So the single value is only one value, first name and only one social security number, for an example. Simple attribute is one that cannot be composed into the component pieces. That cannot be composed into its component pieces. For an example, person 6 is classified as male or female. In between that, we cannot find male or female, and there is no really reasonable way to decompose male or female. So that you can understand clearly what is this multi-valued attribute and simple attributes. Can you understand? Can you understand? I think yes. So that you can understand the difference of these simple attributes and the single valued attribute. Okay, let's see the next one. Here we feel that the last example, student number, simple attribute, name, composite, as I can you hear me? Hello? Can you hear me?
Yes.
Okay. Then student major. multi-value, and date of birth, composite, student hours, simple attributes, student year, single value, GPA derived, and uh, GPA can be calculated from the marks of the subjects or the grades of the subject you have taken, and age also derived attribute. Likewise, you can write. So we have done this one. Actually, previously we gave this example. You have to understand entities and attributes. Entities and attributes for each entity, and domain of each attributes, composite attribute, derived attributes, and primary key of each entity. Let's see here. Shall I give you 5 minutes time to identify these things? Do you need time? Tell me, then I will give you if you want. But as this is interactive sessions, you will have to actively participate for this. So can I give you time? Yes, you can speak.
Okay, sir.
Okay, we'll give you 5 minutes time, and please do. I will give you 5 minutes time. Okay. Now I think you have enough time for this. We'll see. Okay. So then, first of all, entities and attribute for each entity. Yes. And domain of each attribute, composite attributes, derived attributes, and key, primary key of each entity. Let's identify the student name, address, telephone number, gender, DOB, student ID. Student ID is the primary key. Phone has the multi-valued attributes, home and mobile number. Likewise, if you want to have the name, you can give the composite attributes: first name, middle name, and surname. Address also, if you want, you can give as the multi-valued attribute: number, street name, then town, or finally you can give the postal code. Likewise, you can identify. I think you can understand what I am saying it. If you want, you can convert this one also as multi-valued attributes. If you want, here, this one, name also, first name, middle name, and given surname. And address also, you can have the multi-valued attributes if you want. Gender, you know that male and female, single value. And phone number also you can have. And another one is date of birth. If you want, you can have age as derived attributes. Likewise, you can write. Okay, let's go to the next one. The course has the department. The course must belong to the department, and the duration of the degree course or faculty, and course name and the course number. And also you can give, if you want, the subjects for the course subjects. And how do we find the course name of the student ICT 2020-24? If you want to find the course name of the student ICT 2020, this is the student number. So if there are two attributes, how can we identify the how can we uh, identify the student who is following the courses of this student? Let's see, like this. Let's get the pen once again. So then you have to understand how to identify this student that he is following the courses. So we have to have the relationships. For that, we have to have the relationships. Let's see what are these relationships. Huh? When you see this one, having these two attributes, there is no any relation. So there is no any relation. If we want to identify this student who is following the courses, so there is no any relationship in between these two attributes. So next we have to identify the relationships. The relationship is the association among two or more entities. Normally called, the relationship is association among two or more relation entities. The collection of similar relationships is called the relationship sets. For an example, you want to identify not only the previous student, ICT 20 24 024, but also you want to identify ICT 25 025 050. Likewise, the different students, so that each student of this student set may have these relationships. So that we call the relationship set. So the relation now you can see shown as a line connecting like that, the associated entities label with the name of the relationship, so that using this diamond you can write the relationship name. Normally the relationship is the verb or verb group. As I told you before, the attribute is the noun or noun phrase, but the relationship is the verb register. That means student register course. For an example, Lasantha registers ICT course. Example. So in such case, the many students can register in the one course. So when you get the DBMS, all the ICT student must register in the DBMS course. So that means many student, many indicates this N, register DBMS subject or else ICT course. Your batch has more than 70 students can register the ICT course. That is many to one relationship, N to 1, many to one relationship. Then let's go to the next one. So this is called the relationship and relationship examples. When you get the bar has the name, address and the registration number. Consider this is the pub or any other juice bar. So it has address as also name, also the registered number, and that juice bar sells the juice, name of the juice and the manufacturer, and also drinkers also there, the people, the persons who come to drink those juices. So name and address of this. When we can have a relationship like this, juice bar sells juice. In such case, you can see bars sells some juice, and another one is drinkers like some juice. So if you get one person, the get once again the Nimal likes mango juice, then apple juice likewise. And next one is the drinkers frequent come to drink to this bar. Drinkers frequent some bars, frequently come to or frequents better than is comes or to this bar. Likewise, we can find the relationships. So then degree of the relationship. Degree of a relationship is the number of participating entities to the relationship. Understand number of participating entities. Number of participating entities. Participating entities. When you get this relationship, how many entities participated to this one? Student and the course. There are two entities. So the degree, number of entities, 2. That is another one is called the binary relation. So because there are only two entities participated to this relationship. The student registers course. That also the two entities, student and the course. And the binary number of entities for this relationship is 2. Normally we call the binary relation. And degree of the relation is number of participating entities. Number of participating entities. And relationships can be classified based on their degree into binary. That means relationships has two participants. Normally the degree is 2, as I explained in the previous example. Number of entities are 2. And ternary relationship with 3 participants, that is degree or the number of entities are 3. And quaternary, that means relationships with 4 participants, that is degree or the number of entities are 4. Basically we can find the 2, 3 and we rarely find the 4. So but we in our complex database systems we can find this 4 also. So you have to understand what is the degree. So can you explain what is the degree of the relationship? If you could understand, what is the degree? Answer is there in this slide. What is the degree of this relationship?
Number of
Yes,
participating.
just you have to read number of participating entities. So the relationship can be classified based on the degree into binary, ternary and quaternary. Okay, next we will see ternary relationship. Sometimes we need a relationship that connects more than 2 entity sets. Suppose that the previous example which I explained, the drink, bar, juice and people that comes drinkers. So suppose that the drinkers will only drink certain juices at a certain bars. Our 3 binary relationships like sales and frequent do not allow us to make this destination. So but 3-way ternary relationships can also be happen. So these are the typical relationship set. Joe's bar drink Anna comes to these 3 bars, Suez bar and you use this avocado super, apple light and watermelon cool And also Bob used this from this bar, mango light and avocado super, and Joe's and super bar Cal use the avocado and apple light. So this is typical relationship set we can find. As I explained the previous example, we can explain these ternary relationships like this. The here instead of writing like this, we can use the ternary relationship like this. Here, preferences, bar, juice and drinkers. So you can see Anne prefers to drink from this Joe's bar, avocado super and apple light. The drinker Anne's prefers to drink from this Anna's stool juice bar, avocado super and apple light. Likewise, we can have the ternary relationship. This is called the ternary. Sometimes you may have a confusion of this ternary relationship. Don't worry. When we do the practicals and do the design the tables, you will be able to understand this concept very clearly. And next, ternary relationship. Normally, each employee can work at most one department at a single location. Employee works in department. Employee works in departments. This is the location. So employee has these attributes, and the department also has these attributes. The location also has the name and the address also. They are in the location. So here is the example. These are the employee numbers, employees, name, the place, location is Rome, London and Paris, and department. That means employees who are working in a Rome office works in finance department. The employee of this number who is also working in a Rome works in a marketing department. Likewise, we can write. Okay, and also the worker 12243 who works in the London office works in the finance department. Likewise, we can see the ternary relationship like this. So then this will be a good example to understand the ternary relationships. And also 12299 employee who is working in the London office works in a marketing department, D3. So likewise, we can have the ternary relationship. So the binary relationships you can easily understand, and then ternary relationships like this. The employee works in department. This is the one of the good example for that one. The cardinality. The next one we have to understand what is the cardinality. Cardinality ratio for a binary relationship specifies the number of relationships instances that an entity can participate in. So then in the very first example I explained student registers courses. Then many student registers one course, that is n to 1. There are three types of cardinality ratio for the binary relationships. So the binary relationships, there are three. One is 1 to 1, 1 to 1, 1 to 1 relationship. Next one is 1 to many or many to 1. Both are correct. 1 to many or many to 1, which I explained the previous example. many students can register one course. Okay, then next one is many to many, N to M relationship. So there are three types of correlated ratios: one to one, one to many, and many to many. We'll understand one to one relationship. So when you get the employee, for an example, head of department, let's say head of department can manage only one department, but sometimes you will argue that he can be the acting head of the department in a different department. Yes, but he's not the permanent one. So permanently he can manage only one department. Employees manage one department. That is one to one. Employee manage at most one department. The department can have only one manager or the one head that is managing the department. When you analyze the also faculty has one dean. No, you can't find the several deans at once. Only faculty manage one dean. Okay, employee, that is the dean. Next one is, think about the library database and give an example of one-to-one relationship. So I will give you few minutes to do this. Think about the library database. Give an example of one-to-one relationship. Okay, can you think? I will give you 2 minutes for this. Think, what is that? What do you think? One-to-one relationship. Okay, I will give you 1 week for this one, and we'll continue. Otherwise, I can't finish the lecture in time. And one-to-many relationship. An employee works in the most one department, and employee works in department. You can see many employees work in one department. One-to-many relationships, one department and many workers. And also when you get the faculty or the department, many lecturers work in one department. They are not permanently work in one department, attached to one department. When you get the ICT, there are 4 lecturers attached to ICT department. So next, one-to-many relationship. Favorite from drinker to juice, one-to-many. Many drinkers favorite for one juice. You can see the avocado super. Avocado super likes not only one juice but also the ants and the other drinkers. So a drinker has at most one favorite juice. A drinker, the other way, must have at most one favorite drink. But the juice can be favorite in many numbers of drinkers, including the zero or including the zero. So sometimes there is a separate lemon juice. No one likes for the lemon juice. But avocado light, avocado super, avocado light, as well as apple light likes many users, many drinkers, because of the taste or something like that. Okay. So this n can be 0 or n. And think about the library database and give the example of one-to-many relationship. I will check this one the next class, your turns, because we'll continue the lecture and see the exercises in the next class. Many-to-many relationships. Once again, the many-to-many relationships, actually, the employees can work the several projects. A project can have many employees working on it. When you get the projects, so many employees work many projects, attached to many projects. If you see the software projects also, you can see the project the system developers, or he works in different tech leads, works in different projects at once. They advise for the different projects, and also when get the engineers, when you get the engineers, they are handling the several projects. They handle the projects in for an example, the construction project in Colombo, and also they are going to handle the construction project in Pitipana. Likewise, the not only one engineer, but also the several engineers handle works on different projects at once. And likes from drinkers to juice of many to many. Many drinkers like many juices. Many drinkers like many juices in our juice bar example. Because Joe likes not only the avocado super, but also he likes for the apple light also in our example. Then think about the library database and give an example of end-to-end relationship. These are the homework, and next week I will check these relationships, one-to-one, one-to-many, and many-to-many relationships of the library database. Okay. So identify the cardinality of this one. Doctor, patients, principal, school, mother, child, husband, wife, teacher, student. So what are the relationships of the cardinality ratio of this one? Doctor, patients. Can you give this? This is very simple. So can you answer this one? Doctor patient relationship.
One to many.
One to many. One doctor can consult many patients. Okay. And also one to many, yes, one to many or many to one. Many doctors can consult one patient. For an example, if he admitted to the hospital, many doctors see the one patient. For an example, the physician, also sometimes the surgeon also see the many doctors also see one patient, and one doctor see many patients. That also many to many also can be applied. Principal and school.
One to one.
One to one, yes. Principal and school, one to one. Principal can only handle one school. Then mother child.
One to many.
One to many.
One to many, yes. Husband wife.
One to one.
One to one.
One to one. Don't tell one to many, yeah. Teacher student.
Many to many. One to many.
One to many, yes. The one to many and many to many also.
Many to many.
Many to many, yes. Many to many. Okay, then I think you can have an idea about these cardinality ratios. Then descriptive attributes. Consider that this one. Vimal Bandar, 23 years old, a diploma holder, joined to the ABC company as a management trainee. Okay. She joined or he or she joined the production department on this date, 1st of January 2005. When Vimal successfully completed her commerce degree, he was promoted as the finance executive and transferred to the finance department from February 2nd, 2006. Considering her, once again, don't worry about it, there may be a mistake. Considering her MBA qualification, the management of the company promoted him as the assistant manager, business development, and transferred to the business development department with effect from 3rd March 2008. And can you answer the question? I will correct it later because this is a little bit difficult to correct it now. And can you answer this? So descriptive attributes, how you are writing the descriptive attribute for that one, because you know that the dates has been changed with the departments. So the descriptive attributes, the relationship can also have descriptive attributes. That means the used to record the information about the relationship rather than any one of the participating entities. This employee, the Vimal, works in different departments in different dates. So this participating relationship will be explained using some attributes. That is the start date. Vimal works in the production department since 2008. Vimal started works in this company as the you can see as the management trainee, and he joined to the production department. First he joined to the production department, so that you can put the start date 1st of January 2005. And after getting his commerce degree, he was promoted to the finance executive and transferred to the finance department 2006. Okay. Then after getting his MBA, he was assistant manager business development and transferred to the business development department March 8. So the dates, the place he worked in departments in different dates. He has worked in 3 departments in different dates, so that we can write the descriptive attribute. This is called the descriptive attributes, which explain the relationship, in different dates. Here are the descriptive attributes. E011 started works in the HR department in this date, from this date. Likewise, we can write the descriptive attributes. Attribute on relationship. So also we can write the attributes on relationships to explain. The bar sells juice at this price. Bar sells apple super for 100 rupees. Price is the function of both the bar and the juice, not one alone. The price, for an example, Joe's bar sells apple light for 150, and Ant's bar in a different bar sells the apple light for the 120. Likewise, the price function for both bars and the juice, not only one alone. the price is belongs to this one and the juice of that. Then ER diagram. ER diagram means using these relationships of the attributes, you have to write the ER diagram. For an example, student registered the courses and student taking the classes. Relationships typically labeled as verbs or names of aggregation types. Okay, so now I think your turn. And an organization employ 3 people are assigned to departments, and they will work on a range of projects. Every project is responsible for the particular department, but many utils employees from across the organization only include the few critical attributes. So, your turn. Identify the entities, identify the relationships, determine the cardinality and participation, total or partial participation. Okay, so I am going to wind up